Look, ladies and gentlemen, we're just extending what we did yesterday. I broke section one into 2 days. And so our notes yesterday look like this, right? And you have a red star at the top, right? And you got 3 points, 2 points for taking the notes, and 1 point for headphones, right? So if you didn't know that yesterday, that's what happened. I put that into Skyward, and if you missed it, if you felt like you got ripped off, let me know during the period, and I'll take a look at your headphones and see if you have some notes on the beginning part of section one. So today we're going to extend our understanding to using graphs to solve our equations. So let me zoom in on that. Right? So we're going to use a graph to solve an equation, and we're going to look at a word problem, and then you're going to do 6 problems, the first 6 problems on our assignment. And then we're going to talk about how to solve an inequality, and what does that mean, and what's different about an inequality and an equation. Okay? All right, so let's do this. Let's just solve the equation before we look at the graph, okay? We, yesterday, I think, had some success doing that. And it maybe felt kind of good, like, okay, I can do this math. I totally get what I'm supposed to do. And for some people, maybe your skills are a little rusty, or you made an arithmetic mistake and you started beating yourself up. I don't want you to do that. Don't beat yourself up. We're going to get better. That's how you get better at doing this stuff. You practice, repetition, okay? So I would personally add 11 on both sides. There's always options on what to do, but to show all my work, I might do something like this. So I end up with a 3 on the right side, right? 11 minus 8 is positive 3. Or if you're at negative 8 on the number line, okay, if you're at negative 8 on the number line and you're going to try to get to 0, well, that's 8 in that direction, right? How many more do we have to go for 11? Well, we got to go 1, 2, 3 more. So that takes us to 3. That's why that is 3 right there. Then we have 1/2 x still. Well, how do I get rid of 1/2? In other words, how do I make 1/2 equal to 1? Really, I want 1x right here, right? You could divide both sides by a half. Sometimes that's a little confusing, dividing by a fraction. I like multiplying both sides by 2, because 2 times a half gives me 1x, right? Now, I usually don't write the 1 there, because when you see an x there, how many x's are sitting right there? One of them. If I add 3 of them, there'd be a 3 right here, right? But 2 times a half is 1. And then if I multiply the left side by 2, I got to multiply the right side by 2. This is the stuff we were doing yesterday, right? Hopefully it feels real comfortable to you. You're like, yeah, I can do that. So we know the solution to this function, or this equation up here, is 6. The solution is called the root, okay? So the root is also called the solution. In our situation up above, it was 6, right? Okay, so that's our x value. Now, let's look at the graph for a second. So I'm going to switch over to Desmos in a moment, but if I was to graph, well, like what the heck would I graph? I don't even have a y in this equation up here, right? So let me do this. I'm just going to erase all this stuff for just a second, because I said our goal today is to solve by graphing, right? Not to solve it by algebra on this problem. So if I was going to solve it graphically, here's one way of doing it. I could let this thing right here be y, and I could let this right here be a y also on a different line of Desmos. Okay, so what do those two graphs look like? I'm going to deal with y equals -8 first, and I'll show you that. -8 is down here, right? And when we say y equals -8, we're saying all the y values right down here are -8. I don't care what x is. X can be anything. That's called a horizontal line. And usually, it wouldn't be dashed like that. I'm dashing it so that it kind of stands out. That's probably bad form on my part. So let me just put it a solid line right there. That's y equals 8 right there. -8. All right, now let's graph 1/2 x minus 11. Well, I got to go down to a -11, because that's my y-intercept, -11. And then I need a slope of 1/2. So I would go up by 1 to 10, and I'd go over 2. So I'm going to go over to 1, 2, and I'm going to graph my line. So my line does something like this, okay? And it keeps on going, keeps on going, keeps on going, keeps on going. Well, I don't need to keep it going. Where does the line y equals 1 half x minus 11 equal -8? Where does it equal -8? Well, it's right here. It's at that x value. What is that x value? That x value better be 6. Otherwise, I messed up my algebra when I was solving it algebraically. So let's jam over to Desmos for just a second. Let's practice that using some technology. So here I got my y equals 1 half x minus 11. I didn't worry about graphing the easiest one first. I did the left side of my equation. There it is. See down here, -11. And then it goes up by 1 over by 2. So definitely the slope is right, up by 1 over by 2. See, having some skills allows you to check whether the technology is telling you the right thing. Okay. So here we go. Now I'm going to do y equals -8. Okay, look at that. We got the horizontal line. Where do they intersect? At 6, -8. Now, I don't want the -8. -8, I already knew that. That's my y value of -8. This one has a y value of -8 also, right? Like if I cruise along the red line, where's it going to? Oh, to -8 in the y value, and the x value is 6, right? Now, here's what the book does, though. The book says, the book says, let's do this. Let's just add 8 to both sides. I don't know why I'm mumbling about it. I'm just hesitant to even show you this, but it's a valid way of solving it. So if I have 1 half x minus 11 equals -8, I could add 8 to both sides. Okay. When I add 8 to both sides, please keep paying attention to this because this is important, but it's not the only way to solve it. So what do I get? I get a -3 here. So what I'm going to put in my graph is 1 half x minus 3. So think about that for a second. If I was down here at -3 and I graph 1 half, so I'm going to go up by 1 over by 2, my line's going to look like this. It's going to be parallel to that one down there, right? And it's going to be cruising along like this. Where does it cross over the x-axis? At 0, right? So at y value of 0, and x value of 6. This is 6 comma 0. So this is called the 0 of the graph because that's where the y value equals 0. Okay, so they give it a special name called the 0, but the 0 is really just the x-intercept. Okay, so please put that in your notes. That's kind of weird. We see that a lot in mathematics. They'll say find the zeros, or sometimes they'll say find the roots, and the root is the same thing as a 0 if we're looking for when the function equals 0, right? So this, I transformed it. I manipulated a little bit to make it equal to 0. Now watch this. When I graph 1 half x, let's do that. 1 half x. Oops, I don't want the x down in the denominator, right? I want it over here. And then I go -3. Do you see how it crosses right here at 6? It's the same as what we had right down here on this graph, right? So the x value is 6, x value is 6. I get the same solution. I get the same answer. I get 6. Okay, so I hope that makes sense. Real quick, let's look at a word problem before I turn you loose. One of the problems in our homework today is going to look like this. This will be number 7 in the homework. So I do want to modify something right down here. I want you to try problems 1 through 7. So let's do that real quick here. And I'll make sure that's in our Google Classroom. Okay, so the problem I'm about ready to show you, I'm just going to tell you what the answer is, and I just want you to go and put it into McGraw-Hill when you get there, okay? So it says this kid has $100 in her lunch account. Not bad. Nalia spends an average of $18 per week on lunches, so it's 100 minus 18W. So here's her y-intercept, 100, and then she's got a slope of -18. So if we went down by 18 and over by 1, yep, that looks right. Down by 18 and over by 1, okay? So we want to know, estimate to the nearest tenth of the number of weeks that Nalia can purchase school lunches. Well, when does she run out of money? Right here. So the answer to this question is, what is the root, or what is the 0? So here's our 0 right there. Looks to me like about 5.5 weeks. Okay, so we're going to put 5.5 weeks in. Then we're going to solve it algebraically. So when does 100 minus 18W equal 0? I subtract 100 from both sides, and then I divide by -18. Okay, so I get W equals -100. That's terrible. That's really messy. Sorry. -100 divided by -18. And that comes out to be, let's see what happens. 100 divided by 18 is 5.5. Okay, it's 5.5 repeating. You notice I didn't even type the negatives in there because, look, I know the negative divided by negative is a positive. So it's like extra keystrokes and a chance that I might, type something in wrong. So I see that, I do that in my head. It's the part about 100 divided by 18 I want an approximation for. So that's about 5.5. So my little dot over the equal sign means approximately, right? So 5.5, and then I should put some units on that, okay? Hey, put the video on pause, and I want you to do the first 7 problems in your homework. Thanks, everybody. Welcome back. Let's go down to how do you solve a linear inequality? Okay, so what's the difference between an equation and an inequality? Well, just look at the symbol right here. I don't mean to insult your intelligence, but if there was an equal sign right here, it's called an equation. If there's an inequality sign, it's called an inequality, right? So the difference, though, is pretty significant. And you might say, well, of course it is. But look, there's a greater than or equal to symbol right here. This side over here, this side is bigger, okay, big, and this side is smaller. Okay, so it's a comparison. And so it's not the same as an equation. An equation, both sides are equal to each other. They're the same on both sides. So it doesn't matter if you move one side, like to the right and the other side to the left, because you'll still have an equation. You can switch the sides around. However, when you switch the sides of an inequality, it changes things. So like if I was to, just assume all of the properties for equations are exactly the same, then I'd be making a big mistake. And I'm going to point out the property that changes dramatically. And you might know what I'm talking about when you divide or multiply by a negative, right? You got to pay attention to that. And that's what's going to happen. That's why I wanted you to look at this example with me, because we're going to divide by a negative, and it's going to switch the inequality sign. So let's do a little algebra. So if I subtract 12.9 from both sides, okay, so let's see, I had negative 71.9 and I'm subtracting 12.9 more. That's going to take me into negative 84, I think, right? Because if we were at 71.9 or 71.1, excuse me, negative, and here's the 0 over here, and we're going another 12.9 in that direction because we're subtracting 12.9. So at 0.9 and the 1 is going to take me to 72. So pretend like I'm at 72 right there, 72. So I've taken care of the 9 and the 1. And now we go another 12 on 72. That's going to take me to negative 84. That's how I did that in my head. And then I got negative 5.6n. Okay, so let's see. Oh, it's not equals. It's an inequality, doggone it. So shoot, let me fix that. Okay, so we have an inequality. Come on, Nelson. So greater than or equal to, and I got to put my negative 5.6n right in here. Now this is the weird part, okay? Let's say I wanted to avoid this negative. So let's say I don't want to divide or multiply by a negative. I could add 5.6n to this side, add 5.6n to this side, and now I've got 0 greater than or equal to 5.6n minus 84. And then I could add 84. This is the long way of doing it. I don't want really people to do it this way, but I just wanted to show it to you. 84. Okay, now look, 5.6n. Notice the n now is on the less than side of my inequality. And then, of course, I'm just going to divide by 5.6, okay? So let's do that real quick. 84 divided by 5.6, okay? So 84, come on. 84 is going to go up in the numerator, and 5.6 is going to go in the denominator, 5.6, and let's just make sure they're both positives, right? So let me put that in my notes, and I want you to do this. I want you to write this stuff down, 84 divided by 5.6. I don't want you to do everything on the calculator. And so what do we get? We get 15. Okay, so n is less than or equal to 15. Okay, well, let's just graph it. Let's finish this off because they're going to ask us that kind of question. So I would identify where my 0 is, my origin or my reference point, and then I'd go over here to 15. And now we want all values that are less than or equal to. See how n is on the pointy side of the inequality. It's on the less than side of the inequality. This is the less than side. This is the greater than side. So 15 is greater than or equal to all the numbers that we want. 15 is greater than or equal to all the numbers we want. So I'm going to put a dot right here, and I'm going to shade in this direction saying, hey, I'd like all of these numbers in this direction. It's only a one-dimensional graph here. We're not graphing vertically at all. We're just going to the left because it's just one variable in here. So we're not doing that shade everything to the left, like two-dimensionally. We're just going one-dimensional there. All right, let's get back to what I was saying at the beginning. Here is option 2, or I'd say option 1, actually. Let's say I had 5.6n, and I just subtracted 12.9 from both sides. So I'm going to subtract 12.9 from both sides. That's a legal maneuver. So I get 71.1 here. So if I subtract 12.9, I'm down to negative 84. We've already done that arithmetic, okay? Is less than or equal to negative 5.6n. Okay, now watch this. If I divide by negative 5.6n, I get n is greater than or equal to, what do we say that is? That's 15. When I take 84 divided by 5.6, I get 15, right? And there's a negative divided by negative. Now look at this. N is greater than or equal to 15. See, that shades completely the opposite way that we want it to. So when I divided by this negative, you have to switch the inequality sign, because if you don't, your variable is on the wrong side of the inequality. See, like if I move my variable to the right side of the inequality, it's different on the right side than it is on the left side because of the way the inequality sits. So if I'm dividing by a negative, here's the deal. You've got to flip the inequality sign, because moving it to the other side dramatically changes things. It not only changes the sign on the variable, it changes what side it's on. If it was an equation, it doesn't matter what side the variable's on. You can put it on the left side or the right side, you still have an equation. But in inequality, the side that you're on is very important. So we wanted all the n's to be less than or equal to 15. See, like if I move this n to the other side, I got to make sure the inequality is pointing in the right direction, right? N is less than or equal to 15. So it's like I got to switch the inequality sign around if I flip it over, if I move the n to this side, 15 to that side. So you've got to, when you divide by a negative, you got to flip the inequality sign. Divide or multiply by negative. Flip the inequality sign. Flip inequality sign. Okay. All right. Hey, thanks for watching my video. I want you to finish the rest of the homework.